We're delighted this evening to welcome Yusef from Filecoin, who's going to talk to us about the kind of how to build NFTs with IPFS and Filecoin, kind of an on-topic topic that you might want to learn about. And I totally see by a good audience here tonight, everyone is particularly interested in this topic. This is part of the broader Encode Filecoin Club, which, if you don't know what that is a three-part series of education, then hackathon, then accelerator, teaching you about Filecoin, the IPFS, the whole kind of broader protocol labs ecosystem, and showing you ways you can get involved. All these videos, these events, these live events do get recorded and go on to our website, YouTube and Medium for your consumption, both now and in perpetuity. Or until we do the next series. Without further delay, Yusef, it's fantastic to have you with us. Thank you for sparing some time in your busy schedule, and looking forward to hearing everything about NFTs. And over to you.
Thanks. Yeah, it's great to be here. This is kind of my intro to NFTs talk, and I'm going to do some coding and show you guys with bits of JavaScript and a little Solidity and so on. And yeah, I might as well just jump into it. So we are, first of all, I'm Yusef. I work for Protocol Labs. I write code sometimes, but these days I mostly write documentation and try to fill in the gaps of the Web3 developers journey. Basically, like we're trying to ease the pain for people that are new to it and kind of broaden the developer space. So today we're here to talk about how do you actually build a smart contract for unique non-fungible tokens, and how can you use our tech to help? And I'll explain why you might want to do so along the way. So we're going to use IPFS for content addressing so that we can have durable links from our blockchain contract to the outside world. And we're going to use Filecoin for provable long-term storage. The details of actually interacting with Filecoin are going to be handled for us by a service that we'll talk about in a little bit. So our main goal here is to learn how NFTs actually work. What are they fundamentally? Because we want to build digital artifacts that we can trust to endure for the long term, or ideally at least as long as the blockchain that we're building upon. We would like our NFTs to be, accessible in perpetuity. So yeah, we're gonna go through the agenda for the talk real quick. So, got the introduction, which is almost over, so hooray. And then we're gonna talk a little bit about contracts and how they work, and see an example and play with, some code a little bit. And then talk a little bit about data storage, which is sort of where Protocol Labs really fits into the story, and how we can offer some tools to help. And we're going to sort of see what are some of the challenges of working in a blockchain environment compared to traditional web dev and things like that. Yeah, so along the way, hopefully we'll be able to come up with a more precise answer for this what is an NFT anyway question, which I always like to bring up, even for people that are, I'm guessing you guys have heard of NFTs before, but there's so many use cases for NFTs and so many projects and everything else that I like to kind of boil things down to what is the technical essence of an NFT, and in terms of what do you actually get when you exchange your ether or whatever for something. So we'll take a look. Yeah, so then we're going to talk a little about the data storage, how IPFS and Filecoin can help you out, and then a little bit about concerns you might have when you're developing applications. This part is less hands-on and more just kind of zooming out to talk about what are some of the challenges and some tools that you might like to use as you're building applications that interact with NFTs. Right, so talk about smart contracts. So for simplicity's sake, I'm just going to talk about one contract platform, the Ethereum blockchain, which there are now many blockchains that you could potentially develop NFTs on. But when you're dealing with a topic as a bit sort of abstract as NFTs, I find it helps to have one specific instance of the tech that you can actually play with. And Ethereum is the OG blockchain, and also just the one that I'm most personally familiar with. So that's what I'm using to demonstrate. The general concepts would be largely the same for most blockchain platforms, but the specifics will be different. So you might have a different, smart contract language, the deployment setup and the tools you use would be different, but conceptually, the big picture is pretty similar. So let's go over like the super high level. How does a smart contract work, right? And this is ignoring tons of details, but just like from the perspective of somebody that's writing code that wants to interact with, a smart contract, give me the sort of Cliff's notes. So first of all, somebody's going to write the contract itself, and for Ethereum, probably Solidity. There's a couple other languages that are more niche, like Viper, which is nice if you like Python style syntax. But generally speaking, okay, so somebody writes a piece of code that gets compiled to bytecode for the Ethereum virtual machine, which is a specification that all Ethereum miners implement. And the way it works basically is when your compiled contract gets deployed to the network, right, in a transaction, you pay a little bit of ether for this to happen. When the miners all accept your transaction as valid, then your contract now is sort of sitting, it just sort of sits there in the Ethereum state. Like it's available to be called, but it doesn't do anything by itself. But now you can call functions on it and the way you call functions is by submitting transactions to Ethereum miners. But the actual practice of calling transactions feels more or less like writing JavaScript code if that's the environment you're using. So it can almost feel like sort of regular app development, but you have to be aware of the execution model a little bit because you're not actually running the code in the transaction. You're submitting a request, and then miners are doing their miner stuff. There's all kinds of there's no guarantee that your code is actually going to run, but you can sweeten the deal by adding some gas fees and so on, and hopefully somebody will pick it up. Speaking of fees, it does cost money to write data to the blockchain. So read-only functions, like if you're just querying the current blockchain state or looping over as maybe historical information, that is free in the sense that you might have to pay someone to run an Ethereum node for you or run one yourself, but you don't have to pay any ether just to get the current value of the blockchain state. But you do have to pay money for anything that modifies the state. So if I'm going to write something into the blockchain, I have to pay some fee called gas, and that's just a small amount of ether that they recently changed how this is distributed, and it was a big deal. But the essential function of gas is to prevent people from running infinite loops, more or less. Like you want to make sure that every contract has an end state. So eventually, even if you write a terrible contract, you're going to get cut off by running out of gas. And also it helps sort of subsidize the whole execution model. So that's sort of like the very basics of like how the whole thing functions. And then as far as NFTs specifically go, there's a few more properties. So it's like an NFT is a specific, like it is a record in a special kind of smart contract. The only thing particularly special about it is that it has a well-defined interface, and you can define tokens that have unique identities, and that's like where non-fungible comes in. If the whole NFT concept is new to you, the non-fungible bit just means that each token is unique with its own identity, and you can't exchange one arbitrary token for another of the same type. They just have unequal values, and like the reason they have unequal values is because NFTs are used to represent things. They mean something in a way that like an individual ether or a Bitcoin doesn't really mean anything outside of itself. So, but yeah, the other properties that I want to kind of highlight are they can be owned and transferred. So that's sort of what makes them tokens in the blockchain sense. Like they can belong to an account, and you can transfer them to another account. And whoever owns the token is basically the only one authorized to transfer to someone else. And although you can authorize someone else to act on your behalf, generally, if you want. And generally speaking, just because of the limitations of blockchains today, most NFTs are very limited in the amount of data that they can actually store. So you can do some data storage on chain, but it's really expensive if you're talking about any significant amount of data, in the like tens of thousands of US dollars per megabyte range. The actual number fluctuates a lot, of course. But so generally speaking, you want to minimize on-chain data storage as much as possible to basically the things that you need. Like if you have to read some piece of data in order to then write something or make a decision, like let's say you're making a game where like you're building Minecraft on the blockchain and you have a crafting recipe. I need to consume like 3 wood in order to build a shovel. That would have to happen on chain. Like you would have to have all the properties of those things in your smart contract and store that data of like, is this a wood block or not? Because you need to consult that in your smart contract code. You have to like read the state, do something, and then modify state. So that would all have to live on the blockchain. But most properties of your NFT, and especially for art, like digital art and collectibles and things like that, the primary, um, you know, most of the data that describes the NFT lives off chain because it's just, if you have a significant chunk of data, you probably can't afford to put it directly onto Ethereum. And so this kind of raises an issue because the like linking from on-chain data to off-chain data has some subtle, you know, uh, gotcha moments or whatever that we'll talk about in just a second. But before we get there, I want to just briefly mention a few of the standards in the Ethereum NFT space. So the first standard to come out of the early NFT experiments is ERC 721, and it defines this interface this is like the specification basically for the operations that you can do to an NFT, and basically just the ownership mechanics of like, who does it own, like who does it belong to, transfer it to someone else, and so on. But there's also some metadata extensions for linking out to other stuff. So this was the first formal standard. It evolved out of CryptoPunks and other early projects. And yeah, this token URI function here is kind of the piece that lets you link from a token to something else. And the way you link is just with a URI, which could be an HTTP URI, but those have issues that we'll talk about. And so then the other standard that is pretty interesting and has a lot of traction is, oh, sorry, I'm skipping ahead a little bit. ERC 721 also defines a pretty basic metadata schema for NFTs that is a pretty good baseline to build upon because it has lots of support in the ecosystem. So then this one, ERC 1155, is newer, and it's pretty interesting. So it is a more or less an extension of ERC 721, and like it serves a similar purpose, but it is a multi-token standard. So the idea here is that you can have multiple types of tokens, and they can each have their own supply. So you can actually use ERC 1155 to do NFTs and fungible tokens in the same contract. So for example, if you have a game and maybe you want a fungible token for your in-game currency, but then you have NFTs for the magic swords and stuff that you can buy with your game coins, then ERC 1155 would let you do those both in the same contract. And it is pretty cool because like apart from that, it also supports these like batch transfer operations. So if you're wanting to say like mint 10,000 NFTs, you can do it all in one transaction and really cut down on the gas fees and just sort of the overhead involved in doing all of that with the 721 standard. Yeah, so you can do fungible tokens, non-fungible, or semi-fungible tokens, where basically like a token could be exchanged for tokens of the same type, but maybe like, so like maybe all swords are equal, but this is a magic sword, and they could still have an identity, but be roughly fungible according to certain rules that you might define. But basically, like if for the examples later, we're going to use ERC 721 because it's a little bit simpler. But this is definitely something you should look into if you're, heading down this path, because it's not that much more complicated than 721, and you get the flexibility of all these other features. Yeah, it was made for the gaming use case, but it's not gaming specific. It's used by all kinds of places. OpenSea uses it for their NFT collection feature, and there's a bunch of marketplace support now, and it's pretty well established at this point. So I've talked enough, I guess, about abstractions. We are going to do a little, just a quick code along thing. You guys can follow along if you like. Otherwise, you can just watch me type away. I'm going to basically start from 0 and try to get an NFT contract deployed to a local blockchain so we can poke at it. And we're just going to build that up a little bit step by step to get some basic functionality going. So, all right. To do this, I'm going to use some tools that I'm familiar with. I tend to use this thing called Hardhat, which is like a local development framework for compiling contracts and doing like deploying them and all stuff like that. There are alternatives in the ecosystem. It's Truffle is a really excellent tool as well that you can use. It has a nice GUI for their blockchain and everything. But I've been using Hardhat for a minute, so I'm going to stick with it. And Open Zeppelin is sort of the big player in terms of public and well audited base contracts. They provide a lot of functionality, and we're going to use them as the basis of our thing. And then at the bottom, if you want, there's a whole article that we wrote for the IPFS doc site about minting NFTs that goes into detail about sort of metadata choices and things like that you might want to check out. So I'm going to switch over to my terminal here, and I'm using Node.js version 16, NPM 7. Any relatively recent node should work if you're following along. And I've got an empty directory except for I have a little picture that we're going to store later. So first, let's make a project directory. Okay, and go inside, and I'm going to make a new empty npm project and just accept all the defaults. So now I have a package.json file, and I can start installing stuff. I'm going to add save dev. So I'm going to add Hardhat and the Open Zeppelin contracts. And now you get to watch my slow internet download npm packages. But while that's happening, we can kind of, so watch the little spinner spin, and I might go and tab over real quick to the Hardhat documentation. So let's find our web browser here. I'm going to go to hardhat.org. So you can see what we're working with here. So this is kind of where you'll be poking around if you're getting into Hardhat and you haven't used it before. The most important stuff is probably in quick start and configuration. We're basically just going to be following, like doing a standard quick start thing. So here we go. So we have Hardhat installed now, and now I can invoke it with npx, which if you've never used that before, it's like Hardhat is installed locally to my project, and it's tucked away inside my node modules folder, and npx will let me run it from there. So I'm going to say npx Hardhat and just call Hardhat with no arguments. Give me their little wizard thingy, and I'm going to create the sample project and just accept all the defaults. So that will give us like a hello world kind of blockchain development scaffold thingy. And we'll take a look at it and build it up in just a second once everything is done installing. Almost there.
Just while we wait, Yusef,
Hardhat and Truffle.
Sorry,
I
I was going to say
I
we
just
had
saw a question pop up.
a question from Raphael. which is, can we add a NFT from another contract into our ERC 1155 contract?
Not exactly. Like, you can transfer an NFT from a contract into another one. Out of the box, I don't think that it will. Well, let me back up a little bit. You can transfer an NFT into any account, and you can, if you can code your contract in such a way that it can accept an NFT from another contract. So if you've done that, and like you've implemented the sort of receiver end of things, then your contract can become the owner of another NFT. So yeah, it's a little like you have to do stuff to make that happen, I think. But yeah. And then, yeah, there's a question about hard hat versus truffle, and they're fairly similar. Like, they both are kind of like convention over configuration, like frameworks for development. But hard hat, I think the chief differences are, like, hard hat was built sort of as a plugin architecture, and you can use all kinds of different tools with it. But the sort of default, like, beaten path is to use ethers.js, and there's a waffle testing framework that's like really well integrated into it. So, and that stack is pretty like comfy to use, I think, compared to the sort of default truffle path, which tends to be to use Web3.js. They both do the same stuff. I just prefer using ethers. Also, truffle has some really nice features. Like, I like their Ganache GUI thing, which is their sort of development blockchain. Hard Hat has one also, but it doesn't have a fancy GUI, and I don't know. They're both roughly equivalent, so if you like one or the other, you should just use it. That's kind of my take. So yeah, we've got, looks like we're done installing stuff, and now we have this empty scaffold project. So I'm gonna check it out in my editor over here. You can see we have this hello world contract, and we're gonna go and find an NFT contract to put in here. So this is where Open Zeppelin comes into the mix. They have these base contracts that you can use, and I would highly recommend just using them if you're just getting started with ETH. Just like digging into the contract implementations is very instructive. So if you find yourself like, hey, I like this contract, but I want to do something special, you can either rewrite it yourself once you understand how it all works, or just extend it. And yeah. So I'm just going to copy their example straight from the website, and we'll play with it. So this is from their sort of guide to ERC 721. And we're going to make a new file here and call it game item, and paste this stuff in. And now let's make things big so we can read through it. We're here, this is validity. So it's, if you squint, it looks like C or Java or JavaScript or anything else. The semantics are a little weird because it's on the blockchain, but it's not the hardest thing to read when you're just getting started. The fiddly bits tend to trip you up as you're developing further and further. But for now, it's pretty simple. So what we do is we're importing this counter from OpenZeppelin. They have this nice utility library for just incrementing counters. And that's going to keep track of our token IDs. And now we have this award item function, right? So it is going to take an address, and that's going to be the new owner of the NFT. And you pass in the URI for the metadata. It's going to generate a new ID from the counter, and then call this mint function that's built into the base contract. That takes care of all the business of basically mapping who owns what, and this the set token URI function keeps track of like what URI belongs to which token ID. So under the hood, it's really just a bunch of mappings. Like, there's a mapping of token ID to account, and a mapping of token ID to URI. But the base contract bit sort of handles all of the machinery for you. And then that's it. It's super simple because we're deferring everything to the fine folks at OpenZeppelin, basically. So now that we have this in our contracts folder, we can compile it. So, and we do that with hard hat again. So we say npx hard hat compile. And let's see, does not specify compiler version. Consider adding this. That's a good idea. Let's do it. But it's not really super relevant. Okay, is this lady? Oh, all right. Well, at any rate, we're going to go with this contract. Compilation finished successfully. Sounds all good. So now what we're going to do, we have the contract, but we haven't done anything with it. It's just like the bytecode is sitting on this laptop here. So I'm going to talk about deployment, which means taking this contract, wrapping it in a transaction, and sending it off to the network to be incorporated into the blockchain. We're going to use like a little blockchain simulator that's built into Hardhat. So when you, and the way deployment works is you write a little JavaScript, or maybe you can, you can make this as fancy as you want. Like if you have some complicated deployment set up with lots of libraries and things. So, but generally speaking, it's pretty simple. When you run a script with Hardhat, it provides this thing called the Hardhat runtime environment, HRE, and that gets you access to Ethers.js, which is how you interact with contracts. And also it just wires things up for you so that you can connect to whatever network you have configured and stuff like that. So this is the deployment script, or this sample script that comes with the boilerplate thing. And we're just going to modify this to deploy our contract instead of the hello world greeter contract that comes with it. So all we're doing is renaming some variables here. I'm going to rename symbol and call this game item to match our contract name. Get contract factory is built into Hardhat. It's like an extension that Hardhat provides that says, I know that your contracts are probably in a folder called contracts because that's what Hardhat expects. So it's going to go look for that in your compiled output and get you everything you need to deploy it, basically. So to create a new instance of it. So you have to give it the name of the contract. And then now I have this sort of like a factory function, and it knows how to deploy itself to the blockchain. So let's rename this guy also. So uppercase game item is the factory. Lowercase game item is actually an instance of our contract that we can call once it's deployed, we'll be able to like interact with it, stuff like that. The hello world contract expects an argument in the constructor, but ours doesn't, so let's get rid of that. And say game item deployed to game item.address. And that's all the changes we should have to make. So hopefully that worked. I should be able to say npx hardhat run and give it the path to that scripts sample script. We'd probably rename that if we're building a real project. It rebuilds everything and it says, hey, it's deployed. That's great. So we must be done. But not quite, because where have we deployed it to, right? By default, Hardhat runs against a ephemeral simulator that just exists only in memory for like as long as you're running the script. So this is mostly useful for unit tests and things like that. So if I want to test all my contract code, I probably don't need like a real blockchain, and I want it to be super predictable and wipe everything away every time. But if I am building a web application or something like that, I want a contract that's going to stick around so I can play with it, basically. So if you're doing that, what you would do is go and say npx hardhat node, and that runs the same blockchain simulator as before, but now it's like running as a standalone process, and it won't go away until we kill it. So to get our script to use it, you have to either set an environment variable, which you can do like hardhat network equals localhost, and then say npx hardhat run, do your thing. So if I do this, same output over here, but now if I tab over to my blockchain simulator, you can see that something happened, right? So contract deployed, it gives me the address and some other information about it and so on. And now if I could, in a second script, I could now interact with the contract without having to redeploy it and so on. So that's super useful when you're developing a bigger application and you want like a realistic environment. And you can make that change persistent instead of having to set an environment variable. Like if you know you always want to target the local one, you can go to your hard hat config. Lots of info on the docs here, but if you just want to set the default, you can say default network that is localhost, and it will just target it every time. So I might as well leave that. Now if I run it again, it'll deploy a new instance. And now, now I have two different copies of the same contract living on this blockchain. So, all right, not too bad. I think that takes care of challenge number one. So we have the first, we have a contract for now, right? So, and it's just sort of sitting there waiting for us to do something. So maybe we should do something. I'm gonna just keep editing the same sample script, and we're just gonna poke at the contract. So a real app, you would probably use basically the same technique, but organize your code all proper and stuff like that. But we don't have time for that. So let's see what we got. So here we are back. We've just deployed our contract, and now what we want is to call that award item function. And that, if we tab back over here, remember it needs an address and a URI as input. So the address, we're just going to take, Hard Hat will wire you up with, Ethers calls it a signer, like a thing that can sign transactions. So when Hard Hat sets you up, it lets you, especially with its development blockchain, it generates a bunch of accounts with fake money in them, and then you can access them all. When you're setting it, when you're targeting a real blockchain at some point, you'll have to configure it with an account that either has private keys set up and stuff like that. But for now, we can punt on that and not really worry about it. So we're going to say the accounts await hre.ethers get signers. This is going to return the signers for like all the ones that Ethers knows about, and we're just going to say the player is the first one. So account 0, and then but we actually don't need the whole thing. We just want the address. So that's our player. And then for now, I'm just going to make up a URI because we'll get there in a little bit. So let's see. Fake CRD. All right, and to actually call the function, what we do is we'll just say, we get a transaction object out, and we're going to say await game item dot award item player and URI. And now we have this transaction object, but nothing has really happened yet because the transaction could fail. Maybe we gave it the wrong inputs, or we don't have enough Ether in our account, or whatever. There's no guarantees at this point that anything has actually happened. So you have to do this thing called tx.await. Autocomplete messed me up. So with that, also let's make this big again. This is going to block, I had to put the await keyword in here. Now it'll hang out until the transaction has been mined and confirmed. And this happens right away in development with the blockchain simulator, but in the real world, this might take several seconds to, however long the block processing times are. So there's some delay here. Also, in a real app, you would want to wrap this in try catch and do error handling, stuff like that. So, okay, we can wait on this, and at this point here, we'll have our token minted, but we don't know anything about it yet because you can't, even though our contract returns the token ID at the end, you can't get a return value out of a function that modifies the blockchain. This is one of the sort of weird gotchas of the asynchronous execution model. So like, I am calling this transaction function, but I can't really know anything about it until the transaction is complete. At this point, once it does complete, now I can sort of inspect the result. And so what you get out of await it actually returns a value. So if I say const receipt equals tx.await, the transaction receipt is like how the transaction hash and all the information about it, but it also has any events that were emitted by the contract during the processing of the transaction. So what as part of the ERC 721 spec, there's this thing called a transfer event, which gets emitted anytime a token changes hands or when it's first created, which is considered a transfer from the 0 address. This is from to whoever ends up owning it. So we have this receipt, and I'll show you real quick how you can kind of poke at the events real quick. So you say like for event of receipt events to loop over them. And we only care about transfer events, which is probably the only thing you're going to find, but it's good to filter out the things you don't care about. So you can get the type of the event, event.event, and that's just a string with the event name. So we're going to say if it's not a transfer event, we don't care, and we'll just move on to the next one. And now we can say, well, why don't we just log it? Event, but we're also going to get some information out because the event will have arguments, and that includes like who the token is transferred from, who it's to, and the token ID. So I really only care about the token ID right now. So we're going to say token ID equals event.args.token ID. The args will be different for different event types. So yeah, you can learn more about events and all that by digging through the Solidity docs, or the docs for Ethers.js explain it fairly well. Although you do have to dig a little bit to kind of get to the good stuff. There's other interesting things you can do with events as well besides just reading them after a transaction. So yeah, so I guess for now we're just gonna, well, why don't we store the value here? I'm gonna say let token ID equal, we don't know what it is yet, here, and now we're gonna assign it here. And then we'll raise a stink if we didn't find one. So if not token ID, something went wrong. All right. Hopefully we won't have that. But now we're going to say console.log token ID. And once we have the ID, we should be able to, oh, I made a mistake. I'm doing all this before I know that the thing is even deployed. So let's move this up here. We want, yeah, there we go. Okay, so we have our new token, we know its ID, and now once you know the token ID, you can ask the blockchain for information about it, and it will give you information instead of yelling at you and like, I don't know anything about that token. So we should be able to, at this point, say, hey, give me the URI for that token, and we'll expect to get this same value back out. So if I say, let's see, we'll call this one ID equals await game item dot token ID. And this is token URI. This is a method that's built into the ERC 721 base contract. And this, we just give it the ID, and it should give us, the URI back out. Let's see, metadata URI. So we'll say token URI and log that out. Okay, so if everything worked, we should be able to run this thing and see something. Let's see. All right, so now let's try it. tx.await is not a function. What have I done wrong? Sorry, guys. I seem to have been hit by some gremlins. going to try again, but not use the local blockchain, just use the default. That changes things at all. Oh, I'm sorry. It's not called a wait. It's just called wait. That's my problem here. So px.wait. It really isn't a function. What do you know? All right. Hey, this time stuff happened. This is from when I logged the whole event. So might get rid of that so it's less distracting. So let's comment that guy out. Run it one more time. Okay. So we deployed the contract again. We created a new token with the ID. We can convert that to a string to make it a little nicer to read, perhaps. Token ID dot to string. But the reason it needs to do that is because Ethereum numbers can get super big and freak JavaScript out. So they have to use a big number class. And it has our fake CID that we typed in. So, all right, now we're getting closer. We have a token. We can link from the token to somewhere else. And now I will quit with the coding for a bit and talk a little bit about data storage, right? So we're going to zoom out to why would you use IPFS for this, right? And here's my slide that I sneak into all my NFT talks. And we're going to say, friends don't let friends mint NFTs with HTTP links. Why is that, right? So first of all, why are we linking at all? Because storage is expensive, as we talked about earlier. And HTTP links are like the natural thing to grab because like they're super familiar and they work everywhere in web browsers, but they're fundamentally just fragile by design in the sense that the data at the other end of the link can change or disappear without any changes to the NFT on chain. And that for me is the key piece. It's that you want the blockchain record to be the source of truth about the NFT, which an HTTP link doesn't provide because it only tells you where you can go to find the data. And whoever controls that location then controls the actual NFT data. It's likely that arrangement for like maintaining the data, well, it's not, I mean, it is certainly possible that could break down over time. So like what you want to do is kind of have, I think is the sensible approach is to have, instead of linking to a location where you can find your data, provide a description of the data itself that can be used to go find and verify the data. So that's where IPFS comes in. So IPFS is the interplanetary file system. It's been around for a few years, and it's primarily like a protocol for like exchanging data. It's a peer-to-peer content sharing distribution network with lots of other features and so on. And the way it works is you put your data onto an IPFS node, and that gives you a content identifier, CID. That's the string of gibberish that you'll see all the time if you start working with IPFS stuff. So the way it works is they're a kind of cryptographic hash, which means that you feed your data into a function. Every time you feed the same data into the function, you'll get the same output. But if you change the input data at all, even like flip a single bit, you'll get a different output. So we can use this property to make like these really unique identifiers for essentially every piece of data in the world, more or less. So you feed your data into IPFS, you get a CID, and it's fully deterministic, and it doesn't, because the CID always maps to this one piece of data, and because all the IPFS nodes keep track of which CIDs they have, you can just say, hey, this guy over here, do you have my data? I'm looking for this thing. Have you seen it? And they can respond, yeah, sure, I've got that, if they happen to have it. And if they don't, they'll go and ask all their friends, hey, have you seen this guy's data? And sort of like propagates out throughout the network that way. So you can have multiple IPFS nodes providing the data, and the requesting node doesn't have to care who it comes from. They're just like broadcasting out like, hey, who's got my data? And then, that whoever happens to respond and have the data can supply it. So that's kind of nice, and it leads to some, some bandwidth savings, possibly some reduced latency, although there is some overhead to the whole peer-to-peer sharing thing. So yeah. And then, yeah, you've got this property where, like, even if the original provider disappears, you can still get it from somebody else if they happen to have a copy. But there are some caveats. One is that if everybody that has the content, they could go away, so they could disappear, in which case it would no longer be retrievable. However, if somebody later came back with the same content, all the links referring to it would be valid again, which is something that you don't necessarily get if a link dies in HTTP land, where unless you control the original domain, you can't just revive a link in the same way. So that's kind of nice, but you do have to be aware that, like, somebody has to actually be serving the content online in order for it to be retrievable. And then the second caveat is garbage collection. So earlier we talked about, like, once I fetch something, actually, I'm not even sure if I mentioned this, but once I fetch something from IPFS, I'm going to hold on to a local copy for a while. And if anybody else wants it, I'll provide it to them. But those local copies are kind of, transient, sort of best effort caching. You can't really depend on them to stick around forever. So you really have to tell IPFS to, hold on to your stuff. And that's a process called pinning. And you can pin stuff locally to your node. And there's also sort of an ecosystem of pinning services that will help you do, like, hang on to your stuff and provide it from their IPFS nodes, Textile and Fleek and Pinata and so on. And now there's this thing called NFT Storage, which is sort of our homegrown take on a pinning service that also, instead of just pinning to IPFS clusters, it brings Filecoin into the mix. So I'm not the guy to tell you all the details about how Filecoin works. There are many details, but the high level is that it is a incentivized, like, storage network. It uses a blockchain to keep track of storage deals, where you say, hey, you're a guy with a data center, or you have, like, you're a storage provider is the terminology we're using. You have lots of hard drives. I would like you to store my data. And then that request and, like, some details about it get published to this Filecoin blockchain. And then the network will periodically verify that all the data that was agreed upon is being correctly stored, and that it's been replicated as many times as you've specified, and all this. NFT.storage uses Filecoin for persistence. So earlier we were saying, okay, if everybody disappears, then that's a problem. NFT.storage is solving that problem with Filecoin. So you put your stuff on NFT.storage. We're going to add it to IPFS. So we have our own IPFS clusters. We're also using our help from Pinata to get more redundancy in there. And we're also publishing the data to Filecoin. So NFT.storage will basically batch up lots of small pieces of data into the format that is, like, most attractive to Filecoin miners. And they will go scoop it up and store it for multiple years. It also, NFT.storage will periodically renew the deals over time. So all this behind the scenes. But yeah, so it's what I guess, like, the key thing about this is that once your data is gone through NFT.storage and is on IPFS and Filecoin in this way, even if NFT.storage were to go away, and even if every IPFS node that was hosting your data went away, you would still be able to retrieve the data from Filecoin. And then at that point, you could reprovide it to IPFS to make all the links magically work again. And so that nobody ever has to lose access to the data. And we're actually, it's a free service, which is something that people tend to be like, where's the catch about? So I may talk a little bit about that. The reason we can offer it for free is basically the economics of Filecoin right now are the storage providers are making most of their money through block rewards. So basically, by committing storage capacity, you get a block reward. And by storing useful data, basically data that's been verified in a certain way. There's more details about that if you search for Filecoin Plus. But the idea is that like data that flows through NFT.storage is more valuable to miners than any random data they might find because it has been verified in this way. So that gives them a multiplier on their block rewards. So it's actually like worth it to them to store this data, even without anybody directly paying for it. So it's kind of a sweet deal, and we're committed to offering the service free, essentially as long as we can afford to keep the lights on. And if it ever becomes like the case that we had to shut it down, we'll give you 90 days notice so that you could provide another persistence solution. Hopefully that will never happen. And then, yeah, so we're gonna, let's try it, right? I'm gonna quickly toss some data into NFT.storage, and then we can sort of close the loop here and get our NFT data into IPFS and Filecoin, and then link to it from our little toy NFT contract. So if you want to check out there's some documentation for the JavaScript client that I'm going to be using here. It's a pretty simple operation though, so let's see if we can jump into it. First, I'm going to go to NFT.storage and log in. I've already signed up with my GitHub earlier, so skip ahead. And yeah, I'm going to have to make an API token. Let's see, I got a couple, but I'll make a new one for this demo. So, demo, I have a new API key, and I'm going to copy it to my clipboard. So now we'll go back to our little example script. And for this, I'm just going to make a new function since our main function's gotten a little busy. So I'll say async function store data. Let's see. I'm going to hard code my API key because I'm a naughty hacker. But again, real app, you would want to protect your API token. Here we go. So we got that API token, and then I'm also going to have to install the client library. Kind of skipped ahead a little bit. So NFT.storage. All right. Well, while that's happening, let's do a little table setting here. So once it's installed, I know I'm going to have a NFT storage object, and it provides a file object that matches the file object in a web browser. So so I'll import those two things. And I'm also going to need the Node.js FS package to actually read the file. So do const read file equals require FS. We'll use the promise-based API because it's a little nicer. Right, so I'm going to make a NFT storage client. So I'm going to say client equals new NFT storage and pass in the token. API token. And then I'll be able to call store on it once I have the actual data loaded. So I have a file here that I'm going to store, and I'm just going to hard code the path in here. Let's see, it'll be files, nft.jpg, and then we'll say data equals read file, name, and then I'm going to make a file object. This has the same API as the web file object that you would have in a web browser. It's just adapted to Node.js. So I can say, put my data in there and give it a file name. I'll call it nft.jpg. And then the API likes it a little better if you give it a MIME type. So I'm going to say image JPEG. All right, so file, got that. And then I am going to just take my file and give it to the client, basically. And this is where you also supply metadata that gets bundled up with your NFT. So and client, store. And the store method, I'm actually going to click over to the docs real quick so we can sort of see what we're working with here. The store method takes an object that's has these name, description, image fields. Those are the fields defined in the ERC 721 spec and 1155 specs. And also you can add, basically this supports the ERC 1155 and 721 since they're basically compatible at this metadata schema layer. The 1155 adds a properties field where you can put arbitrary stuff. So yeah. Store name, let's see. And image is where you give it the file object. So basically, the sort of nice thing about this is that under the hood, it's going to store your file and then create a reference to the file using an IPFS URI, bundle that up into, or bundle the metadata up into a JSON object and write that out to a file, IPFS file. And so it just kind of like makes the whole process of generating your metadata a little simpler. You can, if you want to use some other format for metadata that doesn't conform to this store method, you can, but you have to kind of do it yourself. So, and if you're interested in that, there's some info on the IPFS doc site that could help as far as like best practices for metadata. But yeah, so this is hopefully pretty close to what we want. So we now have our metadata stored with NFT.storage and the image as well. So now this this metadata object is going to have a URL property, and that's what we're going to feed into the NFT contract. So let's return metadata.url. So now, if I'm up here, I can get rid of this fake CID, and I can say const URI equals await store data. And since everything is hard coded, we don't need to give it any parameters. So hopefully that will trigger the whole loop of loading the file, sending it off to NFT storage, give us the URI, mint the token, and print some stuff out. So fingers crossed. Let's remember to save it first before we. Right. And off to our terminal. Let's try to run the script again. Right. Game item. I probably should have stuck some logs in there to let you know it's doing something, but hey, it worked. The new token with ID 1, token URI, and it gives us this IPFS URI. So I actually don't have IPFS running right now. I'm going to take this and paste it into I'm going to turn it into an IPFS gateway URL. So to do that, take the CID that you have there and say .ipfs.dweb.link. That's the one I always remember. There's a ton of IPFS gateways and you can use any of them. But if I put that in here, metadata.json, that's the stuff. You got to also provide the file name. So yeah, it has all my metadata there. There's another IPFS URI for the image itself. So let's check that out. And then again, I'm just going to manually rewrite this one. CID, toss the uweb.link bit in there. And super slow, so this will take a second. But come back to that. Hey, there it goes. It's very meta. This is my first slide. So cool, we did it. We got stuff into IPFS. It hasn't hit Filecoin yet because it's going to wait until the NFT storage service has received enough data to batch up into a Filecoin deal. That may take a day. So, yeah. Oh, so there's a question in chat that popped up. If we store the IPFS hash in the smart contract, how would the client know the file name? Well, one method is just to say like, the NFT storage service is always going to call the metadata object metadata.json. So you can just rely on that basically and say, just remember the CID and append that fixed string. It's probably the simplest thing. That's assuming that you're only using nft.storage to create the metadata, and you're always going to have that convention. Otherwise, you could just store the whole URI, which is, I think, the simpler thing to do. That's what I would recommend, is just store the whole thing, IPFS //file name, because it doesn't cost that much more to do it, because the way Solidity stores things, like the minimum amount of data you can store is 32 bytes at a time. So generally speaking, like if you have a short file name, then it's not going to bump you into the next like 32 byte chunk of data storage that you'd have to pay for. So like I actually spent a bunch of time a few months ago like trying to figure out, can you shave gas fees off by storing things in binary? And the answer is you can a little bit, but it's not really worth it because it makes everything way more complicated. And generally speaking, storing the CID plus the path doesn't really cost that much. Yeah, as far as like why you would need it, you don't need to store the file name. You can actually store your things in IPFS directly without preserving the human readable file names. But it's kind of like storing it with the file name is just kind of a nicer user experience generally. But if you are super concerned about the space requirements, then you can add your stuff to IPFS without wrapping it in a directory like that. I'm pretty sure that NFT storage has the store function has a flag that will let you do that, or at least you could use the store blob function, which gives you more manual control over how things end up in IPFS and doesn't do the metadata stuff for you. So there's definitely ways that you could optimize on that front. Oh, and then there's another question in chat about what are the NFT metadata standards? How can OpenSea fetch all NFTs metadata? So basically the base metadata standard is this thing at ERC 721. In the spec, actually, let's Google that. They define like a very minimal schema for metadata, which is down here somewhere, right? This guy, the name, description, image. And most ERC 721 NFTs will have at least these three properties. And so you can render a basic something for them, with just that. But then OpenSea themselves define a bunch of extensions to that a lot of people use. So it's worth checking out just their docs. I don't have a link to it right now, but they have a ton of information about the format that they expect. I'm pretty sure we linked to it from this thing called NFT School that we're also working on, which, yeah, if you go to metadata schemas, I'm pretty sure there's a link to OpenSea's metadata recommendations. There we go. Yeah, cool. So let's see. Yeah, I guess we're kind of hitting time close to it, but I'm just going to briefly talk a little bit about some of the big picture stuff and like just to scatter some links around to resources that I found helpful. Basically, if you're just getting started with Ethereum development and like the only thing you take away from this talk is that Austin Griffith is really cool and Scaffold ETH is really cool, then that's great. I did my job. Like this is a really awesome project for people getting started with Ethereum development, especially if you want to bring a front end into the mix. It's like a batteries included boilerplate. If you haven't used it before, you should check it out. And then building on that, there's this thing called the Build Guild, buildguild.com, which has a lot of examples of Scaffold ETH projects and really cool showcases for things that you can do with Ethereum in general, but there's a lot of NFT specific stuff in there as well. This, I'm sure you would Google, but the actual official Ethereum developer docs are really good and is a good starting point, especially for like getting a lay of the land. There's this awesome NFT thing that is again worth a Google and has a big curated list of links, most of which are pretty solid, and it doesn't have a lot of context, but if you just have like an hour to click through, and you'll probably find something interesting. And then NFT School Dev is the thing that we've been working on a little bit at PL, kind of trying to build up the NFT development community and just explore stuff. So you'll see here, there's a bunch of these like 90s style construction placeholder things. We're still working on it, and we'll probably, we're going to fill this in over time. So, but there's still already some useful stuff there. Probably the most interesting thing right now is this end-to-end experience thing, where you can more or less do what we did in this workshop, but you get like a little front end you can click on and stuff like that too. So yeah, and then let's see what else we got. Though, as far as front end is concerned, these are some things that are pretty cool and make just viewing NFTs really simple. And this supports use NFT.spectre.xyz is a little React component. So if you are using React, this is a pretty easy way to just grab any random NFT and render a card on your website, and you can style it and everything else. And then NFTE.app is similar, doesn't depend on React, only supports 721 instead of 1155, I think, but is also another like neat little, hey, embed an NFT in your website kind of thing. And then I wanted to just briefly talk about indexing of events, because that's something that you might end up doing in a larger application where like you want to query the history of like who did this NFT belong to at X point in time or something like this. You can do this with Solidity and Ethers.js and so on by like querying the logs for a contract with a filter and stuff. And it's fiddly and super slow when you have a really large contract with lots of data. So, and as an alternative to that, you can check out this thing called the Graph, which is pretty cool. It's a decentralized indexing service for basically turning raw Ethereum logs into something you can query without going crazy. So they provide a GraphQL interface, and basically what you do is you say, hey, the Graph, there's this contract over here, and these are the things that I care about. And then their infrastructure kind of takes that and produces this subgraph that you can query. So it's kind of cool. It's a little fiddly to get set up, but that scaffold ETH boilerplate has like, it includes everything you would need to get started, indexing stuff, and something to consider if you're building a bigger app that, wants to learn about the historical state of a contract. That's it. That's all I really had. So, which is good because I feel like I've been talking for a long time. If you guys have questions for me, please toss them in. I'll scan through the chat, see if there's anything I missed.
Yeah, I think there were a few in the chat. So yeah, it'd be good to get them answered. But thank you very much, Yusef. That was a fantastic presentation.
Yeah, totally. Yeah, it's always fun talking about NFTs. I feel like my problem is I'll sometimes get pulled into tangents and like, oh yeah, there's this other thing about NFTs everybody wants to know. So as far as like IPFS being slow, like, I don't know. I mean, I think that there are ways to make IPFS fast, right? But fundamentally you are like asking people for data instead of just going directly to a location and grabbing it. So that resolution step is always going to add some amount of latency. Generally speaking, it kind of depends on how popular the content is to some extent, because like, content that's requested a lot is likely to be distributed better and will have more replicas and so on. And it may also already be like cached by IPFS gateways and stuff like that. So in that sense, if you're requesting content through a gateway, you might not actually hit the peer-to-peer resolution phase at all because it'll just be sitting there. But yeah, that only really helps you if you're like, your data is especially popular and well requested. But I mean, worst case, it'll add a second or two. And then there was a question about like requesting non-existent hashes and CIDs. Every node basically would see the request to an extent, but then the way that the request actually works, there's a protocol called BitSwap, and each node keeps track of some information about previous requests. So if you get too much spam from any particular node, you'll just stop responding to them. So there's some basic protection in place. It's not foolproof by any means. Like you could spin up a billion nodes and swarm over the DHT, and there are definitely vulnerabilities there. We're trying to address them in various ways. And one of them is that like when you advertise that you have a piece of content, that advertisement is signed by your key and is verifiable and stuff. But there's ultimately like DHTs are susceptible to this kind of Sybil DDoS attacks that could disrupt connectivity. That said, I still kind of think that it's more resilient than a centralized provider, which could be DDoSed, but then you don't really have an alternative. Because with IPFS, I think even if the network is under a significant attack, the chances that you'll be able to connect to somebody that isn't being attacked are probably pretty decent. So, but there's definitely a chance that you'll get caught in some kind of malicious routing scheme. So that's something where, but as a tangent, if that's something that you're interested in working on, PL research is always like super keen on new approaches to the Sybil problem. So let's see. Let's see, is there anything else that I missed here?
No, I think that might have actually, I think you covered quite a few during the presentation as well. So yeah, I think that's pretty much everything for today, everyone. Thank you again, Yusef, for a fantastic presentation on a very timely topic as well. And just in terms of kind of general admin for the Filecoin Club, we have an event next week, which is something that Yusef mentioned during the talk, which is hosting with IPFS, and that will be given by Fleek. And so be sure to come along to that. There'll be kind of vital information for the upcoming hackathon. And then following that, we have pinning services with Pinata. So I've just put the links to both of those events in the chat, so you can come along to those events as well. But yeah, aside from that, this event has been recorded. We'll kind of get that up tomorrow and put it in the Discord channel in the Filecoin section. So be sure to check that out tomorrow. I'll just put the link for the Discord in here as well. But aside from that, thank you very much again, Yusef, and everyone for attending today. And hopefully see you all next week.
Yeah, thanks so much, everyone. It was super fun, and hopefully I'll see you around the campfire some other time.
Awesome. Cheers, guys.